Okay, this next set of slides is going to cover nuclear fusion, and nuclear fusion is going to be the combining of lighter elements to form heavier elements. And in the core area of stars, that's where the temperature is hot enough and the pressure is such that the lightest element, hydrogen, can then begin to fuse into helium. There's a nice little video you can check out. So what happens is 4 hydrogen nuclei collide to form one helium nucleus. But if you look at the periodic table of elements, there's more mass in 4 hydrogen than there is in one single helium. So where does that mass go? It's converted into energy, and Einstein is accredited with coming up with this idea with his equation E equals mc squared. E is energy, m is mass, and c is the speed of light. There he is. Pretty cool looking guy. So hydrogen fusion occurs in the cores of stars, and when that is happening, you guys, these stars are considered stable. Stable. That means the forces are balanced. So now we got to consider what forces are happening in the stars. You have fusion force out, but what force do you have in? We know and love gravity, and that is the force that's acting in. So these forces are balanced, and the star is stable. So it's not like whipping out and being pushed in, and it's not going crazy. It is stable. The forces are balanced. Once the star runs out of the hydrogen, though, it's a whole different story. But I'll tell you, there's a lot of hydrogen in the core, and stars remain stable for, we're talking millions of years, billions of years, depending on the mass. So this is not a short amount of time. But eventually, though, the hydrogen will run out. And if hydrogen is fusing into helium, then helium is now in the core. The hydrogen's all gone, so helium's there in the core. This star is now considered unstable because the forces are not balanced anymore. You have a whole series of events, but the star is on its way out to die. So if hydrogen's not in the core anymore, we know that the star is unstable and dying, and it's going to enter into a different stage. Other elements, heavier ones, then begin to fuse one element at a time in a domino effect, and I'm going to show you guys in drawings what this looks like. So as long as you get this down in your notes, you'll be okay. Where the star is in its life cycle and the type of star that it is actually dependent on the fusion. And it's not that there's different fusions, it's actually that there's different elements that fuse. So it depends on those elements that are fusing that determine the star life cycle stage that it's in. So, how are heavier elements made? How are they made? And my friends, your body has carbon in it, oxygen, and other elements. You're sitting on a chair that has elements in it. You're breathing in air that have elements in it. Where did all these elements come from? They come from fusion. We start with hydrogen, and we progressively get heavier and heavier through fusion. Nuclear fusion requires extreme temperatures, and those are found in the core of stars. A star is born when the temperature that hydrogen can start to fuse into helium is reached, and that's about 120 million degrees Kelvin. This is ridiculously hot. That's why we don't see these going on here on Earth. Fusion force outward. This is what I was telling you about the forces are balanced. Fusion force outward equals gravitational force inward. I think this might be cut off a little bit, but ultimately the forces are balanced. So fusion domino effect means that you're going to progressively get heavier and heavier elements as the star goes through its dying stages. When a core runs out of hydrogen, obviously it's filling up with helium because the hydrogen is turning into the helium by the Einstein's reaction E equals mc squared, fusion essentially. And when helium that's the only thing in the core of the star, fusion stops, gravity wins, and the core collapses. The forces were not balanced and gravity won. So the temperature when that happens, when things are shoved together like that and gravity's smashing it in, the temperature rises very quickly and triggers helium to begin to fuse into carbon. Carbon requires a higher temperature. Actually, helium first requires a higher temperature than hydrogen, and that temperature is reached when gravity won. So helium can then begin to fuse. And hydrogen around the core, so if the core is right here and you have helium fusing into carbon, that is a higher temperature. So all around it, the hydrogen that's around that in the star begins to then fuse into helium. So you have a stronger force outward because you have two series of fusion reactions that are taking place, hydrogen and carbon. And so the whole star starts to expand. The outside of the star cools, but the inside is raging, even hotter than it used to be. Once the core runs out of helium, of course it's filling with the carbon that it's forming, fusion stops, gravity wins, the core collapses. So it's a series of collapsing and then expanding when fusion kicks in again. Collapsing and expanding. Temperature quickly rises again, triggers a hot enough temperature for carbon to fuse, and on and on and on, all the way until iron is left in the core. If the star isn't big enough, doesn't have enough mass enough to make it to iron, to keep triggering these fusion reactions, then it will stop. And our sun is actually predicted to stop around carbon or oxygen, and it won't make it to iron. So this says the mass of the star is so small that when the core collapses, it does not trigger a hot enough temperature for the next fusion series to begin. So this is what a star looks like when it's fusing hydrogen. The helium inside there begins to, this is helium, the gray, that begins to accumulate in the core. So, but hydrogen is fusing into that helium, and so it's creating more helium in there. But eventually this hydrogen runs out. And so the core collapses, triggers a hot enough temperature for helium to start fusing, and that then pushes the star outward. So before a star goes into a supernova explosion, this is showing you all of the series of reactions that these elements are going through. So we started out with hydrogen fusing into helium. Helium fuses into carbon at this layer. Carbon fuses into neon. Neon fuses into oxygen. Oxygen fuses into silicon, and silicon fuses into iron. And once iron is filled up in the core, the whole thing goes, fusion stops obviously, and it goes, gravity wins, implodes all of these layers, and it's so highly unstable that it just, bam, explodes into supernova. So, my question is, how and where are all of the elements made? Think about it. The answer is fusion, and it's happening in the core of stars.